Hi everyone. In this video, we're going to review lines and particularly slope-intercept form. And what we're going to use is this handout that I passed out, which I think now is a couple class sessions ago. Okay, there's a blank copy of this on the week 8 module. And it's a large packet here. The PDF is on Canvas, and also the solutions that I'm doing here will also be on Canvas as well. Okay, so this is this packet about points, scatter plots, okay, and then also lines, and then eventually about the regression line. Okay, so we're actually going to move forward. So we actually talked about page 1 here. We talked about page 1. Page 2, we talked about the Starbucks cafe latte sizes versus calories. Okay, so we're actually going to skip to page 7 here. Okay, so page 7 is all about where we start talking about lines. This is about finding the slope and the y-intercept of a line and also interpreting the slope. Okay, here, so this is page 7 here. So first things first, we have a slope here, okay, and the slope of a line. Okay. So as you can see, slope talks about the steepness of the line. That's sort of the geometric interpretation here. And we got sort of three situations here: positive slope, negative slope, and zero slope. Okay, so everything is from left to right because that's how in English that's how we read from left to right here. Okay, so or in these Western cultures here. Okay, so so this is going up from left to right. This is going down from left to right, and then this is not going up or down. It's just flat. Okay. Okay. Now, before we jump into the math here, I just want to remind us that when equation is written in slope-intercept form, you have this y equals mx plus b. Okay. The thing that's next to the x, that's the slope. Okay. So this m here is the slope here. Okay. So it might be a little bit hard to see here. Okay. So, and the slope is just the number. It's just the number n, just the number next to x. Okay, just number being multiplied or next to x. Okay, so remember, if you don't see operation there, that just means you're multiplying. Okay, so for example, here in example 1, identified the slope of the line with equation y equals negative 1/3 x plus 5. Okay, the slope is negative 1/3. Okay, so slope here is negative 1/3. Okay. Okay, so that is, I'm going to try to adjust the autofocus here. That's it. Okay, so what we want to do is we want to graph the line, but we also want to interpret the line. Now, before we graph this line, y equals negative 1/3 x plus 5. Okay, so I apologize if it's a little hard to see. It's negative 1/3 x. Maybe I'll just rewrite it one more time here. Y equals negative 1/3 x plus 5. Okay, that's what this is. Okay. Before we graph it, I just want to sort of do some notation. So this is just kind of the, I think the annoying part, but also just the part that takes a little time to get used to, is that there's different notation for slope. Okay, so in algebra, like we're doing right now, this is m. Okay, it's m. It's y equals mx plus b. Okay, but as we talked about in statistics, okay, and in some of the other videos, the notation for slope is b1 or just b. Okay, and this is kind of a annoying thing because the y-intercept is called b in algebra, but in statistics we swapped it up. We're calling it b1, and then on your calculator, it's called b. Okay, So this is kind of a departure from what you usually learn in math, and unfortunately, the math, this is math and algebra, they can't agree, okay, with statistics, okay, but that's okay. So, but moving forward, the slope is b1. So this is the slope notation, okay. Okay, so now with that in mind, okay, but just keep that in mind as you do the stats, okay, as you do stats, just remember that the slope is b now, okay? But in this video, we're going to use the usual interpretations. If anything, if you're ever confused, just remember the number next to x is the slope, the number by itself is the y-intercept, okay? That's easier to remember. Okay, so that being said, I want to graph this line now. Okay, one way to graph these lines, okay, and this is just review, so you don't, if you know, hopefully the mechanics make sense, but you're not going to be tested on being able to do these types of computations. So let me adjust the light here so it's not glaring back at you here. But just understanding the mechanics, I think, is important for interpreting what's going on. Okay, so the slope is the thing next to the x. We just said that, -1/3. And then the y-intercept is the thing by itself. The y-intercept is just 5. But it's not just 5. It's a point. It's actually 0, 5. Okay. Okay, so the y-intercept is a point, and we'll talk about that in a second. It's the point when x is 0. Okay, so to graph this line, okay, well, we need to interpret slope as rise over run. So we'll talk about this on the next page, but remember, slope is what we learn in algebra. It's this rise over run business, okay? And it's the, remember, it's the change in y over the change in x, okay? So I'm going to write that in our shorthand here. Okay, so make sure you check out the crickets and temperature video if you haven't already, so you can see what I mean there, okay? But we'll talk about this in a second, okay? So the way, remember the way you can graph these lines is, okay, well, you know the slope is rise over run, but we also know the slope is -1/3, okay? And what we can do is, well, okay, this negative sign is allowed to go upstairs or downstairs, okay? So we can think of it as a -1/3, or we can think of it as a 1/-3, okay? So just think about, you know, choose one of them, okay, that you want to interpret them as, okay? But remember, just caution here is that this is not equal to -1/3. So you don't put the minus sign upstairs and downstairs, okay? Because a double negative would be a positive, but this is negative. Okay, anyway, just a small sort of thing here. Okay, so to graph this as we would, so here's our coordinate plane here. So I'm just going to label my axes here. So remember, usually, at least for our class here, the x-axis is the horizontal and the y-axis goes up and down. Okay, so x-axis goes left and right, y-axis goes up and down. Okay, so to graph this, okay, so you need to get a ruler. So let's see if I have a ruler available here. You start with the y-intercept here. Okay, so that's 0, 5. And then we're going to use the notion of slope, this rise over run. So rise over run, if you remember, okay, so if we wrote it this way, that means we go down 1, we rise -1, that means we go down 1, and then we run over 3, okay? So we go down 1, and then we run over 3, okay? So 1, 2, 3, okay? So 1, 2, 3, okay? Okay, and so that gives us a point, so about here, okay. Okay, and once you have 2 points determine a line, you can now draw the line here, okay. So this is kind of a awkward line to draw here, just because it's all the way up here. But this is this line, okay. It has a negative slope, so it's going down, okay. And the y-intercept is when the point at which it intersects the y-axis. Okay, that's why it's called y-intercept. That's the y-axis intercept. Okay, so this is this line here. Okay, now alternatively, we didn't have to go down 1 and then run over 3. We could have went up 1 and then run over -3. Run over -3 means you go to the left -3. And you would have still gotten the same thing. If we go up 1 here and then 1, 2, 3, okay, you'll still land at the same point here. Okay? So that's this line here. Okay, so great. So remember, so a couple things to keep in mind is remember slope. Slope is the thing next to x, and it's just the number next to x, not -1/3 x, just -1/3. And then y-intercept is the thing not next to x by itself. Okay, so that's the next part here. Okay, so on number page 8 here on the next page. Okay, it's about the y-intercept. So the y-intercept is the point where the line crosses the y-axis. So I apologize about this. This is kind of a copy issue here, okay? But this is the point where we intersect the y-axis here, okay? And that's exactly when, okay, so crosses the y-axis, i.e. when x equals 0, okay? So it's the point when x equals 0. On line when x equals 0. Okay. Okay. So this definition should make sense because with what we just said here, that it's the number by itself. Because if x equals 0, then you get y equals b. Okay. So if x equals 0, you get y equals b. Okay, so that's why this definition and also the definition where you think about it's the thing by itself, not next to x, okay, those definitions are equivalent. So number not next to x, i.e. by itself. Okay. Okay, so really, there's nothing much here to think about here, but it's the number that's by itself. So here, if we want to identify the slope and the y-intercept, okay, so the slope again is just 2, okay, and then the y-intercept is 1, okay. So remember, it's not just 1, but it's actually 0, 1, so it's a point, not just a number, okay. It's a point. Okay. So before we graph this, I just want to write down the notations for the y-intercept because this gets a little bit hairy as well. So the y-intercept notation. Okay, the y-intercept notation. Okay, so you got some. Okay, we have different notations here. Okay, so in algebra and math, oops, I don't know why I drew this. This brace here, this algebra / math, the notation is B, okay? Just a regular B, okay? Which is annoying because we just said for slope, we call that B, okay? So for statistics, okay, so I'm gonna draw a line here. For statistics, it's now B0, okay? And there's a reason for this, okay? So B0 or A, okay? And there's a reason for this. This is kind of a historic notation. Well, maybe I'll say a few words about that when we get to go back to the examples here. And then on your graphing calculator, it's going to be, remember if you're, you need to use lin-reg a plus bx. Okay, so this is, remember, option 8, lin-reg a plus bx. Okay, this is the one they have to use. Okay, so close parentheses. Okay, so that's the slope. Okay, sorry, the y-intercept. Okay. Okay. So let's graph the line now. Okay, so to graph the line, there's a reason why I'm having us do this, just so we can understand the mechanics. Okay, so remember, slope is rise over run. Remember, that's what slope is. Rise over run. And here you just have 2, but 2 is the same thing as 2 over 1, okay? So 2, any number, think about any number, is the same thing as that number divided by 1, okay? So you can think about it, if you have 2 pizzas and you divide it into one person, then that person gets 2 pizzas, okay? So any number, it's sort of a small fact, is any number equals a over 1. Remember, a over 1 is the same thing as a divided by 1, okay? So we have some invisible math going on here, okay? So anyway, so the point is you can rise to as you run over 1. So the y-intercept is, so let's label my axes here. I got 1, 2, 3, 4, 5. I got 1, 2, 3, 4, 5. Okay. And then 0, 1, 0, 1 is here. Okay. So let me use my other pen. And I'm going to go up to as I run over 1. So go up to, so 1, 2, okay, as I run over 1. Okay. Okay, so, and once you have 2 points, you can draw the line. Okay, that's it. Okay. Okay, so if you need to pause for a second, just make sure that this is okay. What we talked about here, slope, okay, slope and y-intercept here. And then we're going to move on to the next page here. Okay, so take a second, make sure, pause if you need to, pause and ponder if you need to. Okay, so now on page 9 here, we are interpreting the slope, okay, as a rate of change, okay? And this is kind of the point that I want to make here for what we're doing in our class here, and especially in 4.2 with the least squares regression line, is that the slope is a rate of change, okay? It tells us how the y is changing with respect to x. Okay, so remember, just to back us up, in 4.2 and just in chapter 4, we're comparing variables x and y, quantitative numerical variables x and y. And in 4.1, we talk about if there's a correlation, okay? We talk about if there's a linear correlation, and that's given by R. Okay, so just to remind you of this cheat sheet post-it note, is there a correlation? That's given by R. Remember, R is the sample linear correlation coefficient. Okay, but now in 4.2, we talked about this regression line. Okay, so this is the relationship between x and y. Okay, x and y here. Okay, and what the slope is telling us how the y is changing with respect to x. That is what this formula here is. Okay, so remember we just talked about notations here. So in statistics, it's b or b1. Okay, but here it's m. Okay, so in statistics, it's b or b1, and then in algebra, it's m. Okay, so just keep that in mind. But remember, it's the thing that's next to the x. Okay, so if you need to write down the equation, it's the thing that's next to the x. Okay, but in any case, slope is rise over run, and it's a really this quantity here is change in y divided by, okay, the change in x. Okay. So in another video, I kind of said a few words about these words that mean the same thing, but 2 words that mean the same thing is difference and change. Okay, so difference and change. This is a difference because it's subtraction, and then change. Okay, change. They mean the same thing. Okay, so difference. I spelled difference wrong. Whoops, let me cross that out. Difference and change. Okay, they mean the same thing. Okay, so like I said in the other video, if you might have heard make a change or make a difference, okay, and then if you're going to a grocery store and you're paying money and you're paying with cash and you're expecting some change, the cashier has to give you the difference of how much you gave them. Okay, so these really mean the same thing. In any case, okay, that's what slope is. It's the ratio of the change in y over the change in x. Change in y divided by the change in x. Okay, and then sometimes because these are a bunch of words, we use triangle here. A triangle actually is capital delta here, the Greek letter delta. That just means change. Okay, so difference or change. Okay, so if you want to, you have all these notations for difference and change. Okay, the point is that lines have constant change, okay? So this is kind of the main thing about lines, is that the change for a line is always constant. It's just a number here, okay? So for example here we got a line here, okay? You got a line going on right here, and it's going up. It's going up, okay? How is it going up? Well, for every 3 units you run to the right, it goes up, okay, 4 units, okay? So I'm kind of reading it a little bit backwards here, but if you run 3 units this way, okay, it's going to go up 4 units. So 1, 2, 3, 4, okay? Okay, and vice versa. If you go up 4 units, then you run over 3. That's what it means. That's what this rate of change is that in order to stay on the line, you have to, if you go 3 units this way, then you have to go 4 units this way. Or vice versa, if you go 4 units up this way, then you have to run 3 units this way. Okay, now the way that the line works is that this works if you start at any point. Okay, if you start at any points and you do this rise over run business, it's always going to be 4/3 when you simplify this fraction. Okay, that's what it means for the rate of change to be constant. Okay, so maybe I'll write that down somewhere here. Okay, so slope of line is constant. Constant means it doesn't change. Okay, it's constant, doesn't change. Okay, slope, maybe I should say slope of a line. Okay. Okay. So this is kind of important idea, because it tells us how the variables are changing with respect to each other. Okay, so if going back to some of our examples of x is shoe size and y is height, the slope is giving us an indication of how, for example, height is changing if slope is changing. Okay, and that's something we care about. Okay, if we're comparing two variables, is that if one of the variables changes, how does the other variable change? Okay. Okay, and then, oops, let me flip it over here. We have some negative slopes, and like I said before, when you have negative slopes, you can kind of push the negative upstairs or downstairs, but not both. Okay, so for example here, this example here is they want you to find and interpret the slope of the line that passes through these 2 points here. So a fact about lines is that if you have 2 points, they determine a line. Okay, if you draw 2 points, they determine a line. So here are those 2 points. Here's the line. Okay, and then the slope is given by that formula on the other side here that you may have seen before. It's that y2 minus y1 over x2 minus x1. Okay, and the slope here is -2, so it means the line is going down. Okay, so like I did in the previous one, it's helpful if you think of this as -2 divided by 1, and that means that as you go down 2, you have to run over 1. Okay, as you go down 2, you have to run over 1. Okay, and this works if you take any point, if you do any other points. Okay, so for example, if I took this point here, which a little bit hard to see, but this point here is -4, 7. Okay, and let's say I go down. Okay, let's say I go down. Let's say 1, 2, 3, 4, 5, 6. Okay, I go down 6. So I went down 6. That means I'm -6 here. Okay, to stay on the line, I have to run over. Okay, 1, 2, 3. Okay, I have to run over 3. Okay, so so the slope is the rise over the run. So my slope here is just -6 over +3. It's -6 over +3, which is -2. Okay, which is the same thing as what they did here. Okay, -2. Okay, so slope is constant. It doesn't matter where you start on the line, and this is actually what it means for a line to be straight. If you think about what does it mean for a line to be straight, okay, if you kind of think philosophically for a second, what does it mean for a line to be straight? One of the definitions is that the slope is constant. Oops, slope is constant. Okay, that's one way to think about straightness here. Okay. Okay, so before we stop, I just want to say, okay, so these problems are for you to try here, okay, but I'll post some solutions later on if you want to look at it. I just want to quickly talk about page 12 here, some of these word questions, and then connect this back to what we're doing with some of the examples, the crickets and temperature, and then the, I guess, the lemons and car crashes, okay? And then the rest of this is kind of, it's for you to look at, review. If you're interested, you can read, look at this at yourself, but this is stuff that we won't need to worry about after this section. So this, the rest is completely up to you. These are sort of optional. Okay, so maybe I'll just write here, rest optional. But if you're going into the business, it's good to have some background with some of these materials. So I will at least post the solutions if you want to check these out. Okay, if you have questions, feel free to ask. Okay, so before this video gets too long, I want to just talk about interpreting the slope here. So this one I'll let you try. Okay, but 6 and 7 here. Okay. Okay, so our video streaming service charges a monthly subscription fee of $7 per month. Okay, each rental costs an additional $2. If X movies are rented in 1 month, the total monthly charges may be expressed as y equals 2x plus 7. And we want to interpret the slope. Okay, okay, so so slope here, okay, so you probably have already written it down or just already know what it is. Slope is 2, okay. But before we even talk about slope, it's probably a good idea to just remind yourself what's x and y. X, okay, so x here is the number of movies rented in 1 month. Okay, so that's x. Okay, so x. And the total charges is y. So x is the number of movies rented in 1 month. Oops, I can't spell. In 1 month. Okay, and the y is the charges. Okay. Okay, so sorry, my hand's in the way here. Okay, so y is the charges. Okay. Okay. Okay, so we said the slope is 2, but what does the slope mean here? Okay, what does the slope mean here? Well, remember, slope is rise over run. Okay. So if you have this understanding here, you understand what's going on in the graph, then you're like almost there. The next level of understanding is just remember this is the change in y over the change in x. Okay, the change in y over the change in x. Okay, so that means if x changes a certain amount, then y also changes a certain amount too as well. Okay, so and how does that change, okay, relate to each other? It's by the slope. Okay, so here's one way to think about this. Okay, the slope here too, this is the amount that you have to pay, okay, for an additional rented movie. Okay, so if x goes up by 1, then you got to pay an additional $2. Okay, so that's one way you can think about this. Okay, so if x increases by 1, okay, so if it's changing by a +1, okay, then y increases by 2. That's one way you can think about this. Okay. Okay, and that should make sense because we just said slope is rise over run. It's the change in y over the change in x. Okay, so, well, remember we can write an over 1 here with this invisible math here. Okay, so as x goes up by 1, the y also has to go up by 2. Okay, that's what the slope is saying here. Okay, so you know, if you rent two more movies, okay, so 2 additional movies here, then your cost goes up by 4. Okay. Okay, so this number is often called the marginal cost. Okay, so this is often called in finances or economics. This is often called, so this is called AKA a marginal cost. Okay, it's how much you have to pay to do one more, to rent one more. Okay, so that's what this slope is. It's talking about this change here. So if x increases by 1, then the y also has to increase. How much does it have to increase by? By 2 in this case. Okay, so let's take a look at this one here, and then we'll reconnect to some of the previous examples, and then that's it. Okay, so number 7 here, the value of a new car is $22,500. Suppose that each month the value decreases by $310. Okay, so you have a new car, but over time it depreciates because of usage or because of whatever happens here. But here the value of the car decreases by $310. Okay, so the value of the car after X months, so remember here X months here can be expressed by y equals negative 310x plus 22,500. Okay, so by now you probably already guessed the slope. Okay, the slope is the thing next to the x. Okay, so we got that down already. But what does this mean here? What is this negative 310x here? So maybe pause and ponder for just a second. What do you think this x represents? Okay, so maybe pause. Okay, so hopefully you thought about this for a second. Okay, well, what does this mean here? Okay, so if we think about what's going on, remember slope is rise over run. Okay, this is that delta y over delta x. Okay, so one way you can think about this is that, okay, if a month goes on, if a month we have another x here, x increases by 1, then each month your car decreases, the value of the car decreases by $310. Okay, so literally you could just say this is if x increases by 1 month, y decreases, okay, then y decreases, okay, and it's decreasing because of the negative by $310. Okay, so this is often called the depreciation rate. Okay, so maybe I'll just, this is AKA depreciation rate. Okay, depreciation rate. Okay, and this is the change here. Okay, so this is always how you can think about slope. Slope, whichever letter you want to use, okay, is if x increases by 1, then the y increases or decreases, it changes by the slope. Okay, that's always a way you can think about slope. Okay, now usually it gets a little bit complicated to think about slope that way, so we try to get some convenient numbers. Okay, so now I'm going to go back to some of the examples that we talked about earlier. Okay, so these are the crickets and temperature. Okay, and then also the lemon and car crashes here. So this one we did in class on the ConferZoom. Okay, and then the crickets and temperature I did on a separate YouTube video that it'll be in the description if you want to look at that. Okay, so I'll start with this one here. But we saw that that the regression equation using our calculator is this equation here, y equals 27.628 plus 0.052x. And the slope here is the thing next to the x, is the 0.052. Okay, so what this is saying here is, if you want to think about this, this means that, okay, well, if x increases by 1, okay, if x increases by 1, then y increases by this. Okay, so maybe I'll just write that down on a little post-it note here. Okay, so if x increases by 1, okay, if x increases by 1, then y increases by 0.052. Now, well, we have some context here as to what x and y here is. Okay, so if x is, okay, well, x is chirps in 1 minute. Okay, that's what we said in the other video. Okay, if x increases by 1, then the y increases by 0.052. That means the temperature increases by this much. Okay, so if we are investigating crickets and we hear that the chirps, okay, are increasing by 1 chirp in 1 minute, so we hear an extra chirp, then the temperature, the predicted temperature goes up. Okay, okay, so I should actually say predicted. Okay, so predicted here. Okay, so that's what this is saying here. Now, this is a little bit kind of hard to think about. So if we go back to this example here that we had before, suppose that there's 2 groups of crickets and the number of chirps differs by 50 chirps. What is the predicted temperature of the environment of the crickets? Okay, so this one here, remember, we were given the change in x is 50, and we want to find the change in y. Okay, that's because change and difference mean the same thing. Okay, so you're given that the change in x, the number of chirps in 1 minute, is 50. The change in y is the temperature difference. That's what we want to find. Okay, and by that rise over run formula, okay, the change in y is really just the slope times the change in x. Okay, so slope is, remember, slope is change over y over change over x, okay? Okay. And, well, this is when you do this out, okay? So if you need to, make sure you, I'm a little bit frozen. That's not good. Okay, so now, okay, okay, we're back. Okay, so the change in y over change in x, remember, as we wrote down several times, today already, the slope is rise over run. It's delta y over delta x. If you multiply the delta x to the other side, okay, you get that delta y is equal to delta x, the slope times delta x, which is 2.6. Okay, so what this is saying is that, okay, if we have a change of 50 chirps, if you hear a change of 50 chirps, there's going to be a predicted change of 2.6 degrees Fahrenheit. Okay, so if the number of chirps increases by 50 in 1 minute, then there's a predicted change. This is a predicted change. Maybe I should write predicted here. In temperature by 2.6 degrees Fahrenheit. Okay, and this change is kind of important quantity here. It's very much important quantity here to talk about the relationship between 2 variables x and y. Okay, in fact, there's a nice formula here that I will write down here. Okay, so in fact, it turns out that the linear correlation R, so this is the thing that we talked about in 4.1, okay, your linear correlation coefficient, R, is related to the slope, okay, so this is in statistics, this is the B1, okay, this is, again, B1 is the slope here. Okay, and there's a formula that relates the two, okay, and it's given by the standard deviations. Okay, so I just want to, I'm looking up to make sure that I write down the right formula here. Okay, and it's given by Sx over Sy. Okay. Okay, where Sx is the standard deviation of x and Sy is given by, is the standard deviation of the y variable. Okay, so you don't have to worry about this, but basically these two concepts, so this is the thing in 4.2. Okay, and S is standard deviation. Sx is SD of x data. Okay. Okay. Okay, so that's it. Okay, so let's stop here. Make sure you watch the other video on the crickets and the temperature if you have any questions. And if you have questions, let me know. You can leave a comment in the comments below, or just email me. Okay, bye-bye.